Hello and welcome back to UI Made Simple. This is the reward series, and in this tutorial we are going to create the collectible rewards that can be obtained by claiming each challenge when it's completed. We have already done this in Blueprint, so this is going to be a C++ tutorial. If you are not interested in C++ for your project, then feel free to skip ahead, because we are only going to talk about C++ implementation in this video. For these rewards that we have here, we would want to create an enum to differentiate between the types of rewards, and then we will generate for each entry set of rewards that we will set in our data table. So let's head into our C++ files. I already have my rewards entry button class opened here. This is the widget that we used to generate the entries in the list. So it is this button here. Open the class for this button, and then the second class that we will be using, it will be the rewards menu data, which is where we need to add some rewards. Let's start by adding an enum so we can differentiate between the different types of rewards. So enum, let's call this collectible reward type. And we have three types of rewards. We have gems, we have rubies, well, it will just be singular actually, gem, ruby, crystal, and we also have XP. Let's make this blueprintable. Make sure we can use it in Blueprint as well. And another good practice is to make the enum uint8 classes. Class collectible reward type, and then make sure it extends from uint8. Once we've got our collectible reward types, then we can add some rewards for each challenge. So where we have our challenge data row type, this is the data that we have set into the data table. After the objectives, we can add a T-map for collectibles. So this will be a new property, edit anywhere and blueprint read write. And it will be a T-map of type E collectible reward type and int, because we need to assign this value. It will be an int 32 because this int is relatively small. Let's call this collectible rewards. Right, now that we've got our collectible rewards, we can save this file, stop the process, and relaunch Unreal to make sure that this actually works. Once Unreal is back open, let's head over to our data folder, find the data table that you're using, and then we will see that for each entry that we have in the data table now, at the bottom we have a map of collectible rewards where we can add different rewards. You'll notice that when we add them, it adds them in the order that the enum has them created, but you can also change these. Just make sure that you don't have two entries with the same enum ID, otherwise it won't work. So what I'm going to do is I'm going to go through each of them, assign a few rewards for each entry, and give them some value so we can preview something once we start generating them. For example, 50 gems, 100 rubies, and 10 crystals for this Phantom Blade challenge. I'll skip ahead and I'll see you in a second. Okay, I have added my rewards. As you can see here, they are clearly random with no specific numbers or anything, just different. Some of them have 3, some of them have 2, and so on. So we can preview something once we have them generated. If we head over to our C++ files now, we want to make sure that the collectible rewards that we have added for our rows are also passed into the entry button. And for each collectible reward that we are getting, we are generating one of those rewards widgets which we had created here. If we head over to the widgets folder, you see that we have a rewards box that we've created for the widget. So we want to generate one of those for each of them. To do this, we will have to add another class for our rewards box. So in C++, if we head over to the rewards folder, right click and then add another class. Yours might not be an Unreal class, it might just be a simple class. In this case, we want this to be extending from a user widget. Let's call this rewards collectible reward box. Let's make this class abstract, make sure this is not instantiable. And in here, we want to be able to, when we generate this reward, we want to be able to change a few things. We want to be able to set the background and the reward icon because they all have different backgrounds and icons per reward. And we also want to be able to change this amount text, which is a common numeric text block. To do this, we will need to create bindings for the reward, the background, the icon, and the text. So let's do this first. Now that we have our bindings, we can also create some public functions to be able to set the data in this box. What I'm going to do is I'm going to group the background and the reward icon and pass in the type of reward, so we will be able to swap between the types of background and icon based on the enum. And I'm going to have a separate function for the amount text, so we can change the amount from a different place. So let's create first a function for setting the images. Let's call this set reward graphic, and we'll pass in e collectible reward type. This enum can also be forward declared. It will look a bit strange at the top. It will just use the enum class forward declaration like so. But do not worry, when we use it in the CPP, we will include the header and you will know exactly what we are pointing at. So we're going to pass in the reward type. And then we're going to have another function to set reward amount. And in this case, we are going to pass in an int, because this will be just the amount text that we want to set. Let's generate those two in the CPP. Let's leave this reward graphic aside for a second and do the reward amount because it's more straightforward. So we will use the amount text for this. First, we need to check if we have an amount text. So if the amount text is valid, then we want to set the current value of this amount text. Because this is a common numeric text, we can set the value directly, and this will take in a float. But we can also pass in an int and cast it to the float. So reward amount, and it will automatically cast it for us. We don't have to worry about that. Also, you've noticed that when I call this value, when I call this function to set the value, it also automatically included the header for me. If your IDE does not do that, then you might have to include this header manually. What I'm going to do for this reward graphic is I'm going to create a mapping for my images, so I can only so I only need to set them once in the editor, assign them a type, which is our enum type, and then we will pass them to the background and the icon. So in the header of the reward box, I'm going to create a new struct, which is going to be a use struct. It will be a blueprint type struct, and then I will call this f collectible reward graphics, and then in here I will have two fields which will have to be a U property edit anywhere, so we can edit this in the editor. The first one will be a T soft object pointer for a U texture 2D. This will be the background texture. We can assign this as null pointer, like so, and then the second one will also be tsoft object pointer texture 2D, which will be an icon texture. For clarity, let's put public up here as well, although they by default will be public in the struct anyway. So we have now a struct which will give us the background texture and the icon texture. But what we want to do is map this struct to the types of the rewards that we have here. For this, we need to create another property in our reward box, which will be a U property edit anywhere. Let's give this a category as well, so we can find it more easily. We can call it rewards graphics, reward graphics. And this will be a T-map again, similar to what we did for the data table, but in this case the T-map will be between e collectible reward type and the struct that we've just created. So f collectible reward graphics, and we'll call this collectible graphics mapping, like so. If we now go to our set function for the reward graphic, what we can do is first let's be safe and make sure we have a background. So if the background is valid, then we want to set the background from there should be a function set brush from soft texture. This method will accept an T-soft object pointer, as you can see up here, a uTexture2D, and we can grab our collectible graphics mapping that we have now and then find the mapping for our reward type, like so. One thing that we do need to make sure first before doing this is that our collectible graphics mapping actually contains a reward type, otherwise this will return a null pointer and it will crash. So if the collectible graphics mapping contains a reward type, well, if it does not contain a reward type, then we want to return here, because we don't have anything mapped to this type in the graphics, so we won't be setting anything for the background or the icon. And then we can copy paste this if statement, replace the background with the icon, and then instead of grabbing the background texture, we can grab the icon texture. Okay, just to finish up with this widget, I am going to restart my Unreal to make sure that we add these mappings onto the widget. Okay, my Unreal restarted. I have opened my rewards box widget. The first thing that we need to do is head over to the class settings, make sure that this extends from our rewards box class that we've created, save and compile it. And then if we head back to the designer, somewhere in here we should have a section for reward graphics. There it is, and then we can add our 4 types of structs, because we have 4 types of rewards: gem, ruby, crystal, and XP. So now we can assign the reward, the background texture and icon texture for each one of those. I'm gonna speed ahead and see you in a second. I have assigned all my backgrounds and the icons to their corresponding sections here. Now I can save and compile this, and we can head back over to code. Now we have those 2 functions, the set reward graphic and set reward amount, that we can call from anywhere because they are public, as long as we have a reference to our collectible reward box. Let's go back to our reward entry button. So this was the button that we generate in the list, and now we need to loop over the collectible rewards that we're getting from the data table and instantiate a reward collectible box for each reward that we're pulling out of the data table. And then using the data, we are going to customize the graphics and the amount. So we had this native onList item object set, which was firing every time there was an entry generated in the list, and all we were doing is just grabbing the title. However, we do have access from the challenge entry object. We have access to the collectible rewards as well. So to keep things nice and organized, I'm going to create another function called generate collectible rewards. And in this function, I'm going to pass in the T-map of rewards that we're having. So I'm going to pass const T-map e collectible reward type, and then the int for that reward. I'm going to pass this by reference, and let's just call it collectibles. We will call it from the native onList item object set, generate collectible rewards, and it will be the challenge entry object, challenge data, and then we have the collectible rewards. Perfect. Now we have access to all the collectibles that this entry has, so we can loop over them and generate our widgets. We will need to use both the type and the int. So in this case, I might want to grab the keys from the map first, and then we will loop over the keys. To do this, we need a const t-array of e collectible reward type, and this will be keys, and then we can generate the array by calling collectibles get keys, and then we pass in the array that we want to write into. I can't write into it because it's const. There we go. So we can't assign it directly here, but we can add it into the keys array below, like so. Because there are as many rewards as there are keys, we can now loop over for each key. So for each key that we have in our collectibles, we want to create a new widget, which will be a type of rewards, collectible reward box. So we'll have a U collectible reward box, new collectible, be a create widget. This will be of type U collectible reward box, and then in the brackets the owner of this new widget will be this class. If we head back to the header of the entry button, let's create a new U property, edit anywhere, so we can modify it in the editor, and we'll call this the subclass of U collectible reward box. Add the forward declaration for this, and we'll call it collectible reward template. Let's initialize this as null pointer, and then in the editor we'll be assigning our widget to this template. Now that we have the template, we can pass it into our create widget function, like so. We have created our new collectible widget, and now we have access to it, so we can set the properties that we want, more exactly the graphic and the amount. So we can call new collectible set graphic. We already have the key, which is this collectible key, and then we have the amount as well, because we can call the collectibles map with this key. That's how we grab the value from a T-map, by calling the collectibles map with its corresponding key, which is the one that we're looping over here. Now we are creating these widgets, but we are not adding them anywhere onto our button. We are just creating them into this meta space. They will not be displayed anywhere on the viewport. To display them somewhere, we have to assign them to a parent in the viewport. If you still have Unreal open, if you head over to your button for the challenge entry, if you remember, we created this horizontal box to be the host of our rewards. So we want to add them to this horizontal box called rewards here. To do this, we first need to reference our horizontal box, and then we can add a child after we've created it here. So I'm going to add another binding for my horizontal box. It will be a bind widget, the object pointer, U horizontal box, forward declaration, and I think it's called rewards. Like so. And now we can grab this rewards. Let's first check, before we even try to generate those rewards, if the rewards box, the horizontal box, is not valid, then we want to abort this entire operation, because there will be nowhere to add them. So we'll add an early return here, like so. It doesn't like it because we haven't included the horizontal box header, but it will be added automatically in a second. Now we have our rewards. We've already checked it. It will be valid at this point, so we can add a child to this box. That's it. It included the header now. If you need to add the automatic manually, it is component/horizontal box. We add a child, and the child will be this new collectible, like so. Okay, let's save everything and then stop the process and see what we've got in Unreal. If we head over to our button in Unreal, we see this is already parented because we've done that last time when we generated the list entries. And if we go to our details panel, we should see somewhere here the collectible reward template. Make sure you assign the widget for this one here because we want it to be of this type. If you save and compile this, let's see what it would look like at runtime. If we click play and open the menu, we see that we do not have any rewards for our entries. Now if we go back to code and we go to our rewards menu widget class, this is the entire menu class. When we load the data table and we grab the data from the data table to put it into our UObjects, we didn't actually grab our reward collectibles. So we need to make sure that our new list entry object here has the rewards, collectible rewards as well. So we'll do new list entry challenge data collectible rewards will be the found row collectible rewards to make sure that this is set as well. Okay, we're back in Unreal. Let's hit play and see what happens. Now we see that we have got our rewards, but we are experiencing some rather interesting duplication here. You see that every single reward is added again and again when we scroll up and down, and this is because of something that the list view does, and that is a process called virtualization, where the list view actually only uses the widgets that are into view. So you see those entries here don't have a problem. It's just the ones that disappear completely out of view when we scroll up and down that get duplicated entries. We can very easily fix this by making sure that our rewards array is cleared before we attempt to add more widgets to it. It is because the list view caches the widgets and reuses them when it needs them again. So let's do that. Let's go to our rewards entry button, and before we add a new reward here, we'll make sure that if the rewards box already has some widgets of type collectible reward box, we are going to reuse that specific object instead of creating a new one here. For this, we'll need to set up some object pooling for our rewards widgets. So I'm going to create a local array for my widgets for the rewards box to make sure that we can use it. So in the rewards entry button, let's create a new U property, and this will be t-array of U collectible reward box existing rewards. First, we need to make sure we need to check what we have in our rewards box. So let's once we've checked if we have a valid rewards box or horizontal box, then we want to grab all the children from this rewards horizontal box. So we'll do get all children. This function will return us a t-array of U widget. So I'm gonna grab this t-array of U widget and call it reward widgets. Is that? Then we are going to loop over those reward widgets. So for each reward widget in rewards widget, I don't like the fact that it comes by default with auto, so I'm going to put this U widget in front so I know what I'm looping over. Then we want to check if our widget is of our desired type, which is a collectible rewards box in this case. So we can cast this to U collectible reward box, collectible widget, and cast U collectible reward box and our reward widget. We also need to make this one const because the source is const, and if it is, so if our reward already contains this widget as a reward box, then we want to add it to our existing rewards. Add collectible It's a collectible widget. Don't think we can add it if it is a const, so I'm going to remove the const like so. But this one can be a const reference of children. So all we're doing this is basically looking at our widgets rewards horizontal box, seeing what children this box has inside. By default it will have none, so the first time we call this for loop it won't find any children. And if it does find any children then next times, then it will add them to these array. We should probably use add unique in this case because we only want to add a single widget of that type. And when we want to generate our widgets here, we will check if we already have an existing collectible widget, and instead of creating a new one, we'll set the graphic and amount to that widget. If we don't, then we'll have to create a new one. Because this will be index based, we'll probably have to transform this for loop from a for each loop into a classic for loop. So I'm going to change it to an int 32 I equals 0. I would be less than the keys array, and then I would be increasing. And now we want to first check if we have an existing reward widget, reward collectible widget. So if the existing rewards is valid index at I, then we want to grab that widget and set the data inside of it. So we'll have a new collectible reward box existing collectible widget. It will be existing rewards at I. And then we want to copy those two lines and set them into our existing collectible widget. We don't have the key anymore, but we can grab it from the keys array with the index I. And same here, we'll have to grab the keys array with the index I. We can just cache this for readability. So I'm gonna make a current key. It would be keys at I, like so. Let's take this outside of the if. So first we'll grab the key, current key, and then when we set it, we'll just use this current key here. We had this from the for each loop earlier, but now we don't have the for each loop anymore, so we need to grab it like so. There. Okay, so if we have an existing reward collectible widget, we are going to customize that reward widget. If we don't have an existing reward widget, then we want to create a new one, set the graphic and the amount, but we'll be using our current key. And then here we want to add it to the rewards box and also add it to our array. So our rewards widgets array needs to contain this key now, the add unique, and it will be our new collectible, because otherwise we won't track it here. Okay, so let's quickly recap this because it might get a bit confusing. When we generate the collectible rewards for this entry, we first want to check what the rewards widget has inside, and if it has something inside, we want to add it to this existing rewards. One very important thing that we forgot to do is that we need to clear this existing rewards array before we try to do this operation, otherwise we're just adding on top of existing ones. So we're grabbing what's been already generated. If there's nothing generated, then we can skip over this part. Once we start generating the rewards from the data, then we check if we have an existing reward, we want to set the data in that one, otherwise we want to create a new reward. However, we still have an issue here, because if we have more existing rewards generated from, I don't know, previous generation, and less rewards, those existing rewards that were already there will be visible. So we'll end up with a mix and match of both. We will have to implement some sort of toggle between them. One way to do this is we can set all of the existing rewards to collapsed when we generate them, and then if they do have data, we'll set them to visible. Another way is to just do a more complex for each loop over whichever array is larger, whether it's the keys or the rewards that rewards widgets, and then hide the rest based on the difference. Let's do the collapsed by generation option because it's a bit easier. So we can, after we add the widgets that we found to our array, we can set them to collapse to make sure that they are hidden by default. So we can set the visibility to slate visibility collapsed. And then if this collectible reward widget has had some data assigned to it, on either case, we want to set it back to visible. So it'll be the existing collectible widget that we found. We want to set this to a slate hit test invisible because they don't need to be hit testable. If we are creating a new one, then the new one will be visible by default, so we don't have to worry about its visibility. Let's see what we've got with this. Let's save and recompile the project. Let's see what we've got. If we click play, open the menu, and now we see that if we scroll down and back up, the Serpent's Fang has one crystal orb, I think I called it gem, and then if you scroll all the way down and scroll back up, it stays as one gem. It doesn't add any more rewards to those existing ones. This is exactly what we wanted. Now, one thing that is bothering me a bit is the fact that these rewards are generated exactly one next to each other. They have no padding in between them, and I would like them to look a bit more relaxed because at the moment they're a bit crammed on top of each other. So I don't like that. Let's add some padding. If we head back to our rewards entry button, when we generate those widgets, then we want to pass some padding to them. Padding is a bit of an interesting concept in Unreal because we don't add the padding to the object itself, but to something called a slot component. So if we click on any widget that is parented by a horizontal, vertical box or overlay, it doesn't matter. I will use this label in a vertical box as an example. If you look in the details panel, you will notice that there is something called a slot for a vertical box slot, and this is what holds the padding inside of it. So what we need to do is grab the slot from our widget, cast it to the corresponding slot. In our case, it will be a horizontal box slot because rewards is a horizontal box. And then we'll have to set the padding to that slot. First, we need to know what padding we want to set. So I'm going to create a variable for my padding. This will be an edit anywhere F margin because this is the property that holds the padding, and I will call it collectible reward padding. This is again in the entry button, not in the collectible rewards box. So this is where we generate them. And then if we go down to where we add the child here, so if we don't already have this widget generated, after we add the child, because it needs to be added to the rewards box first, I'm going to grab the slot from it, which first it will be a U, I think it's by default a U panel slot, so it will be new collectible, new collectible slot. It will be our new collectible, and then simply find the slot. But the panel slot by default does not have a function to set the padding inside of it because not all slots allow for padding. So we'll have to cast this slot. So if our panel slot is a U horizontal panel slot, horizontal box slot, you see when I click that, it automatically included the header for me. If you need it, it is components / horizontal box slot up here. So if our collectible is a horizontal collectible slot, we want to cast it, so our panel slot, we cast it to a horizontal slot. And now we can call the set padding on the horizontal collectible slot. And this is where we're going to use our collectible rewards padding, which we've exposed there. Let's also refactor this a little bit, because we can separate this function, this logic here, into a different function. So I'm going to create a new function called gather existing collectibles, and I'm going to copy this, including the check for the rewards, and then delete this bit here, move it into this function, and then call gather existing collectibles from here, like so. Okay, so we've set our padding, and now we should see some more relaxed entries for collectibles. Let's recompile this and check. Once Unreal has reopened, first open the challenge entry to make sure we set the padding to something. So if we scroll down in the details panel, after our template widget, we should see this collectible reward padding here. I'm going to give it about 5 to the left and 5 to the right to make sure that it is, they've got a bit of space between them. Now, if we play the game and open the menu, we see that the rewards, the collectible rewards now have a little bit of space between them, so they look a bit more arranged. You can increase the padding if you like, or give it a bit of top and bottom padding. It is entirely up to you. One thing that we have not set for our reward box is, if you remember, this was wrapped in a size box because our rewards were supposed to be dynamic, because they are reused in both the entries and the details panel, and we had 2 sizes for them. So we could have them either as 90/90, or we can have them as 150 by 150. We just got lucky that our entries by default were set to 90 by 90, but we should probably pass in the type of reward that we want to set. To do this, we need to add an extra function to our rewards box to make sure that we can set which size of tile we want for this, whether it's a small or a large one. So in our class for the collectible reward box, I'll open these two. After we've bound our widgets, we also need to bind our size box here. So it will be a t-object pointer view size box, add the forward declaration, and I don't think we've named that. Let's call this collectible size box. I'm going to copy this. New size box, collectible size box. This will be a null pointer by default, and then we will have 2 vector choose, one for the large size and one for the small size. So new property edit anywhere for this one, and we'll call it, and we'll put it in a category called sizes, and we'll have a f vector 2 d for small collectible size, which we can assign it here by default. So we have some default set. This would be 90 by 90, and I think these are floats, so 90.0f by 90.0f. I'm gonna move this under my edit anywhere section so they're all together, and then I'm gonna copy this vector 2, paste it, and I will have a large collectible size, which will be 150 by 150. Okay, now we need to set this to something. Considering we've only got 2 of them, we can either control them by a bool, whether it's small. If it's not small, then it will obviously be large, or we can create an enum and set them by an enum. I would prefer to keep it as a bool for now, just for simplicity's sake. So I will create a new function, a new public function, set collectible size, and this will take in a const bool. It's large, it's small, for example. So if it's small, then it will use the small one. If it's large, it will obviously, if it's not small, it will obviously use a large one. So first check if we have a size box. It was called collectible size box is valid. Well, if it's not valid, we can return early. Then if it is valid, then we want to set width override, and then we'll have another one for set height override. Okay, if you have to include the header manually for this, the header for the sizebox is component slash sizebox up there. And now for the width and height, we can simply insert a ternary for which size we want to use. Or if you prefer, you can put this into an if else. So if is small, then set the width and height, else set the width and height. I prefer to use a ternary because they are quite simple. So if the width override is small, question mark, yes, if it is small, the first one is true in the ternary, so we'll use the small collectible size, then colon, large collectible size. This takes a float and we're passing it in vector2, so make sure that you're passing it for the width. It will be the x of these two values, like so, capital X. And then the same thing will be for the height override. If this is a small collectible, then we want to use the small collectible y this time. Otherwise, we want to use the large collectible y, like so. And now we will take this set collectible size method, and we are going to call it from where we are setting up our rewards. So first we need to call it from the existing collectible reward widget, set collectible size, and in this case it will be true because this is a small collectible. And when we create a new collectible, again, we'll want to call this with true again, because it is also a small collectible. We are using the same entry widget, so it will still stay as true. Okay, if we save and recompile this, let's see what we've got. While the project loads, there is a bit of duplicated code here. You see we are setting the same thing twice. We could probably refactor this in its own function and called initialized collectible, where we're passing in the key, the value, and whether it's small or not. I will add this as the project loads in the background. In the rewards entry button, let's call this void initialize. And we have to pass in a couple of things. First, we need to pass in the collectible that we want to initialize, because this is a variable, collectible widget. Then we want to pass in the type. So this would be e collectible type, collectible rewards type, and it will be a type. You can make this const. And lastly, we want to pass in the amount, so in 32 amount. Okay, let's generate it, and I'm going to copy, well, cut actually those 3 lines, put them in here, and now our collectible will be the collectible widget for all of them. Current key will be the type, and the amount will be the amount right here. And it's asking us if you want to make this static. You don't have to make it static, but now we can call this function from here with the new collectible current key and collectible set current key, and then we can call it from here as well, but we'll have to call it with the existing collectible instead, like so. Technically now we should not see any difference because we've set the defaults already to what we wanted in our reward box. The sizes are already set to 90 and 150. So if you play this now, we'll see that nothing changes. They are exactly the same. But just to double check that this works, what I'm going to do is I'm going to set the size for the small collectible to be 45 by 45, and this should make the entries half their size. And let's check. yeah, you see our entries are super small now, which means our logic works, and this will be super useful when we'll have to set up the details panel, because those will be larger. So I'm going to set this back to 90 by 90 and confirm that this is back to normal as it should be. Yeah, we've got our collectibles back to working. And I'm going just quickly recompile this because I have added new code after the project was compiled, just to double check that this initialized new collectible function actually works. Okay, Unreal is back up and running. Let's hit play and open our menu, and we see we still got all the collectibles with their data as they should be, even with our refactor. This will be everything for this tutorial. It is a bit long, but I hope you've learned something new and this was useful. This is how you will normally generate widgets at runtime, which are not part of any list view that is generated based on the dataset, and how to get the panel slot and cast it to be able to set paddings and loads of other properties that the panel slots offer. So if you ever want to make dynamic UI, this is how you would be generating your widgets. Thank you for watching, and I will see you in the next one.